Hello friends, welcome to online school. And now let's talk about how to differentiate trigonometric functions with multiple angles. In a previous video, we looked at how to differentiate trigonometric functions with single angles from first principles. Now here, let's look at how to differentiate this multiple angle, and it is sine of 2x. Now we begin by adding small changes, so we shall have y plus change in y equal to sine of 2 into x plus change in x. And here you also take note that it's not sine 2x plus change in x like this. This is completely wrong. So it's supposed to be this other way around. And then so after that, we can subtract the two equations, and then we shall have y plus change in y minus y equal to sine of 2x plus 2 change in x minus sine 2x. Alright, like that. And so this one here, it can simplify to change in y equal to sine of 2x plus 2 change in x minus sine 2x. So after that, we can then apply factor formula to this expression here. And then so here, we happen to find that we have sine alpha minus sine beta equal to this. And then so if at all, we can let this 2x plus 2 change in x to be our alpha, and then 2x to be the beta. So we shall have our alpha equal to 2x plus 2 change in x, and then our beta equal to 2x like that. And then so from factor formula, let's apply factor formula. So from factor formula, we shall have change in y equal to 2 cos of 2x plus 2 change in x, which is the alpha, plus the beta, which is 2x. The whole of this being divided through by the change. Oh, we are not yet there. It's being divided through by the 2. And then sine 2x plus 2 change in x minus 2x. All of this being divided through by 2. And then so we can simplify this to get to change in y equal to 2 cos. Then this one here, it will give us 4x plus 2 change in x divided by 2. So we shall have 4x plus 2 change in x. All of this divided by 2. And then sine 2x minus 2x, here we shall remain with 2 change in x over 2. Shall remain with 2 change in x over 2, which is the same as sine of change in x. And then so we can divide through by the change in x on both sides. We shall have divided by change in x, in this side divided by change in x, to have and so after that, we shall have this as our change in y over change in x. But then remember that dy dx is equal to the limit of change in y over change in x as change in x approaches 0. Alright, like that. So on taking the limit, we shall get to the limit as change in x approaches 0 of 2 cos. Now remember, this is 4x and then this is 2x. So this can be reduced to 2x plus change in x. So we shall have cos 2x plus change in x, right, like that. And then sine change in x. And then we have the whole of this expression here being divided through by the change in x. So here we have divided by change in x. Alright, now when we reach that step there, we can take the limit, and then we shall apply how to get the limit of sine change in x over change in x. Hope you still recall that. So you're going to find that as you take the limit, when the change in x is approaching 0, this is what we are going to remain with. Remember, we have that sine of a small angle is approximately equal to that small angle, but then we take the angle to be in radians. And then in this case, we have this small angle approaching 0, so meaning that it will be very small. So we shall remain with something like this. This change in x, it will just get to 0. And then so we shall remain with 2 cos 2x for this first part here. And then so this other side, so we shall have this. For example, you take an example, you know that the limit of sine theta or sine change in x over change in x, the limit of this as change in x approaches 0, it is going to give us a 1. And then how to come to that? It's that when the change in x or this angle here is getting so small, so we shall only be remaining with something like change in x over change in x to give us a 1. So it's the same here. So it means that the whole of this part here, it will give us a 1. And then so we shall have 2 cos 2x times 1, which is the same as 2 cos 2x. So from that, we can draw the answer that the derivative of sine 2x, which is our y, that's why we said dy dx, is equal to 2 cos 2x. And then after doing that, we found the derivative of a trigonometric function with multiple angles. And then so in the next video, we are going to talk about how to differentiate trigonometric functions with higher powers from first principles.